So our new topic is OSPF. OSPF stands for Open Shortest Path First, and it is a IGP protocol and its routing protocol, interior gateway routing protocol. Mainly will use this protocol is on our LAN side as well as whenever the ISP guys also will use because it's open standard protocols. It will be work in Cisco devices as well as non-Cisco devices also. So basically OSPF it's a routing protocol that is open standard routing protocol. It's a open standard routing protocol. And OSPF it's basically link state routing protocol and will use mainly in interior gateway protocol means inside of organizations. Likewise will use IGP. It's a IGP protocol, interior gateway protocol. And basically OSPF will use a metric because see whenever we configured OSPF routing protocol in between two routers, for example, router A and router B, it's a router A and it's router B. In between, we configured as a link state routing protocol that is a OSPF. Once we configured both end with the command of router and OSPF. Apart from that, we'll use here process ID. Process ID like 10, whichever the process ID. At one end we configured that is OSPF. Then they both try to establish a neighborship in between two routers. So once we configured in router A also and router B also. So they are started they once we configured with this, then we advertise some with network command. Then only they start the process of OSPF. So they will share entire routing table and all. Anyway, we'll discuss. But here it is a link state routing protocol and it's open standard protocol and it's mainly IGP protocol, interior gateway protocol. And it will be used as a metric as a cost. So what is cost again? It will be used a SPF algorithm again. SPF apart from that Dijkstra algorithm we'll discuss anyway. Wait. It will use as a metric as a cost. In that it will be used 100 Mbps divided by interface bandwidth. It will be used this formula bandwidth. This is the formula it will be used, and in RIP protocol it will be used as a hop count, and we have another EAGRP protocol will use as a metric as a K values, but
Hi,
in
Aviv.
this, yeah, hi,
You are explaining the OSPF protocol, right?
right,
This is link state routing protocol that comes under.
exactly. Yes, links under
Okay,
it's a link state routing protocol. Yes, we discussed.
okay, got it. I just want to confirm
So,
before listening that.
so see, just now we started. OSPF stands for Open Shortest Path First, and it's an open standard protocol. It means we'll use in Cisco devices and non-Cisco devices also. In non-Cisco also will use, as well as in Cisco also will use. It's not a particularly Cisco proprietary protocol. Not a Cisco proprietary, it's open standard protocol, and Cisco as well as in non-Cisco also will use.
Okay.
And it's a link state routing protocol. In link state routing protocol, we have a ISIS and OSPF. Two routing protocols we have in link state routing protocols, and EAGRP also kind of link state only. It will be work in both link state as well as and the distance vector also. That is the reason we call it as a EAGRP as a EAGRP is a advanced distance
Advanced distance
vector.
vector.
Exactly, advanced distance vector routing protocol. That is the reason we call it as advanced distance vector routing protocol. And it is IGP protocol and interior gateway routing protocol. What does that mean? It will work within a AS. It will work within a AS. So that is the reason it will work within AS number, autonomous system number.
Autonomous system number.
Exactly.
Okay.
Within AS it will work.
Okay.
So it will be used as a metric as a cost. So in that reference bandwidth by reference bandwidth is equals to 100 Mbps by interface bandwidth, and interface bandwidth we know as well. So like fast Ethernet having F fast Ethernet link having fast Ethernet having how much 100 Mbps MB, and Ethernet link having 10 MB. Ethernet link having the interface bandwidth is that is 10 MB, and serial having bandwidth is 1.57 MB, and 1 gig having how much 1000 MB, as we can verify from here also. This is the one of router CLI mode enable, show interface, gigabit 0 by 0 by 0. See, its bandwidth is this one, and you can check here in MBPS 1000 MB what we discussed here, and fast Ethernet having 100 MB likewise. You can calculate likewise. So metric is a cost, so we'll take here for first one 100 MB divided by 100. So we'll get is a 1, that is this one. We'll get for this 10. We'll get for this some value. You can calculate it, and here we'll get 1 only. 0.1 will get, but we'll take it as a 1 only. For that serial interface bandwidth is 100 by divided by 1.57, then you'll get the value 63 something, 63 kbps something. So the value here like 63. So 63 kbps something. Likewise, we'll calculate likewise the bandwidth. Anyway, I'll show you in lab. Once we configured both end routers, that time we'll get the cost value. That time we'll discuss more about it. But this is a formula how the metric it will be calculated with the cost. So this is a cost. So in between two routers, so here we have a prefixes whenever we are advertising. So if you have multiple path, likewise, so Here in between two path, it is there two routers. So whichever the less cost, less is best. Whichever getting the less cost, that is best. So every interface having some bandwidth, based on that it will be calculate the path. Got it?
Yes.
It will be used as a AD value, that is administrative distance value 110. It will be used AD value, administrative distance value is 110. So for what administrative value it will be take? It will be select the best path based on the AD value also. Means we configured here in between RIP also. So here we configured OSPF.
110 administrative distance is by default.
Is by default only. Every routing protocol having different AD value. So tell me what is the RIP AD value and what about the EAGRP?
For the EHRP, it is 10.
For RIP,
How much EAGRP is?
it is one.
RIP is?
1.
So here we configured as a static. Then tell me static AD values.
Static only 1. Static EAGR AD value 1 by default.
Here 110. OSPF is 110. Then EAGRP is and RIP. RIP is not 1.
For EHRP, a total route it should be 5.
5 is for actually summarization. Whenever you configure summarization, that time it
So
will
it's
be used
170.
5. So 170 is for external. 170 is for external routes. Means whenever we configure redistributed routes, that is AD value, it will be get 170.
Yeah.
Tell me.
For,
RIP and
for
EHR.
RIP, it is 120.
Okay. Then what about the EAGRP?
EAGRP. $90.
See, EAGRP having 3 AD values. One is summarization for 5 and external prefixes means redistributed. Means here you configured as a in between you configured here OSPF and OSPF, and here you configured EAGRP. So whenever you redistributed these prefixes in EAGRP, that AD value it will be get 170. But in EAGRP prefixes, that time it will be get 90. So whichever having the less AD value, that route is the best one. So EAGRP, if we configure 3 path from source to destination, so here which one is the lesser value? Tell me which one is the less one? So that will become a best path. In this case, we have a EAGRP that is having 90 only. So that is the less value. In these 3 cases, it will be elected as a best path. So that is a first it will be what will see highest prefix, whichever the highest prefix, then it will be remove the AD value. If AD value also match, if you configure here OSPF and OSPF only, here you are not configured EHRP, then OSPF, here also OSPF and here also OSPF, that is AD value is 10. So this is also OSPF. So in that case, it will be OSPF, here also OSPF, and here also OSPF, and here also OSPF. So AD value is match. Then it will be moved to the metric. So whichever having the least metric, less metric, that will be elected as a best path. First, it will be check highest prefix, and then it will be moved to the AD value. Then it will be moved to the metric. If metric also match, then it will be load balanced.
Load balancing.
Yes. This is how the router will elect the best path. And basically, it is a layer 3 protocol. OSPF is a layer 3 protocol. Now tell me, RIP is which layer, in which layer it will work? RIP is which layer protocol?
Layer 2.
RIP is layer 7.
Application
L7
layer protocol.
is L7. And EAGRP?
So it's a layer 3 protocol, network layer protocol.
Same. Yes. Is this also L3 protocol, layer 3. And we have a one more protocol, BGP. That is also layer 7 only. BGP as well as RIP, both are BGP,
Layer
both are layer 7, and layer 3 protocols are EAGRP as well as OSPF.
OSPF.
And EAGRP, both are layer 3 protocols. And it will be use a protocol number. What is protocol number? It will be used a protocol number, that is 89. So what will do with the help of protocol number? What is the reason? What is the requirement of protocol number? To identify the service. So for what identification? Whenever we configuring the ACLs and all, so ACL, so some traffic will be deny or permit. We need to permit some traffic. We need to deny the traffic. So basically, we'll use these protocol numbers. With the help of protocol number, we'll deny the traffic or permit the traffic. Permit or deny the traffic. So with the help of, that is possible with the help of protocol number only. That is protocol number is 89. And what about the EIGRP protocol number? EIGRP protocol number. EIGRP protocol number is 88. This is 89 and EIGRP protocol number is 88.
So like when a router sees a packet, when it has a protocol number 88, so it's thought that it is a EIGRP information. So that it contains the EIGRP information and processing
Yes.
accordingly, right?
Yes, will majorly will identify that service. So whenever coming from in TCP and UDP protocol, where it will work in layer 4, right? What it will be do whenever we are sending the traffic and whenever we are receiving some traffic, so we have to identify which traffic is coming, in which path, which protocol basis that traffic is coming. So we have to identify that survey traffic. We have to identify some traffic through which protocol it is coming. So that is the reason this is the protocol number basis will identify the service. So in ACL also, with ACLs, if we don't want the traffic, we can deny. If we want the traffic, we can permit. So some protocols we have, those protocol will use those protocol use some protocol numbers, that is what for identify the services. And it will be used to multicast IP addresses. So 224.0.0 for all the router, 224.0.0.5 and 224.0.0.6. It will be used two multicast IP addresses. It will be used two multicast IP addresses. In that, this is for all the routers, and 224.0.0.6. This is for DR and BDR. So what is DR and what is BDR? We'll discuss. Just wait. But it will be used. So in between the two routers, once we configured OSPF, so they form the neighborship. So they will exchange hello packets. Hello packets. They will exchange in hello packets. In this hello packets, what is the content is there? In that hello packet, OSPF version will be happen, router ID will be happen, and DR, BDR, which one is the master router, which one is the slave router, and in that hello packet only we have a content, entire content is there. So which content, how many prefixes we advertised through OSPF, entire prefixes advertisement, those will be with the basis of 224.0.05 and 224.0.06. With this multicast IP addresses only, they will exchange the information. This router A to send to router B with multicast IP address, that is 224.0.05. With this, they will exchange the information. And what is DR router and what is BDR router? See, this is, we have a multiple routers. We configured multiple routers and OSPF. These all are in OSPF. We configured in between. So they all are neighbors likewise to each other. And this is a full mesh topology, you can assume. So router 1, 2, 3, and 4, and 5. Basically, this is our LAN side network, we can assume. So here we have multiple prefixes. Here this router having multiple prefixes, and this router having multiple prefixes, this router having multiple prefixes, and you can assume like branch 1, branch 2, branch 3, branch 4, branch 5, different branches we have, and different routers. So in this all the devices, only one router having a DR. DR means disaster. Sorry.
The
Wait.
designated router.
Exactly, designated router. Sorry, designated router, and one more we having BDR, that is backup designated router. BDR, backup designated router. So how it will be elected? DR and BDR. First, priority. They will check priority. Priority by default, priority is 1, and up to we can configure 1 to 255. We can change also. We can change 0 to 255. If we configure 0, it won't participate in DR BDR election. If we configure 1, then by default priority value is 1. Whenever we configure as a OSPF, so by default priority is 1. So up to we can extend that value 255. If 255 is there, that router always, it is a master router, DR router. First, it will be check the priority. If priority is tie, then it will be moved to the router ID. Whichever having the router ID, highest router ID, that router will become the master router. Whichever router having the highest router ID, that router will become the DR, designated router. So how it will be elected? router ID. How we have to give, how we can configure. So manually we'll configure router ID. Manually we'll configure router ID first preference, and if we not configured manually router ID, then it will be moved to the highest physical interface. And if we not configure highest physical interface also, then it will be moved to the loopback interface. Whichever the loopback interface highest, that will be elected as a no. First, it will be check loopback IP address. Loopback IP address. What is loopback IP? So it is a virtual interface. Virtual IP address means we can configure as a any interface. Likewise, just move to the config terminal, then interface loopback and give here anything. Up to how many? This many loopback interfaces we can create it. So it's a virtual interface. 100 I am giving. So I am giving the IP address also, like we can configure IP address 1.1.1.1 and 255.255.255.0. So we can verify it. Show IP interface brief. This is a loopback interface. If we configure loopback interface, that will be become as a router ID. If we not configure loopback interface, then it will be moved to the highest physical interface. Whichever we'll configure for this router, whichever, if interface fast Ethernet gigabit 0 by 0 by 0 by 0, and IP address like 1.11.1.1.1 and 255.255.255.0. This is the physical interface. Whichever having the best highest physical interface means this router having multiple interfaces. In this total interfaces 1, 2, 3, 4, 5, whichever having the highest IP address, that will be become as a router ID. In 3 phases, it will be manually will configured and loopback interface and highest physical IP address. If we not configured manually, mostly we'll configure in real time router ID as a manually only. So what it will be do? Router identification. So this router identification for part, and this is the router identification. That is the name of router. In simple manner, that is the name of that router. Router ID is a identification. So it will be elect based on that, and that is DR and BDR election. DR is a master router in LAN segment, and BDR as a, if DR is goes down, this DR router goes down, then BDR will become as a DR router. So all the in between they will use 6 IP address, 6 multicast IP address, and all the routers, that is 5. So 224.0.0.5 for all the routers. They'll send the updates to DR. They will send the updates to DR. And one more thing, this is a we'll discuss states also, but here DR BDR election will be how it will be happen. Any doubts?
No.
Good. So actually, by default, it will be maximum 4 path. What does that mean? If this is
So
our
Alim,
routers. Yes, tell
so
me.
you said that it will select the highest priority, right? Like the router with the highest priority, it will select the DR, right? The designated router.
Yes.
So if both the routers have the same priority, so how can it select the designated router?
So first, by default priority is how much? By default, every router having priority, that is 1 only. So priority always 1 this router having one priority, and this router having one priority, and this router also, this router also, this router also, this router also. So priority is unique, that is one by default. But priority is type. So priority basis, that router is not elected as a DR. If you want to change, yes, you can change it 255. Whenever you configure as a 255 manually, you can change. How you can change? Just IP OSPF, and here priority is there, and priority you can change likewise up to 255. If you change the priority, how much 255, this router will always the DR router only. So priority basis that will be elected. If priority is 1111, then tie. Then what will be happen? If priority is tie, then it will be moved to the router ID. Router ID having different. Every router having different router ID. Router ID means the IP address, 32-bit IP address only. We have to give the manually 1.1.1.1. And whichever having the highest priority, that router will become the master router. Got it? Priority will tie always, but router ID won't tie. It will be not tie.
Okay, the router ID should be unique for every router.
Yes, it will be
Got it.
unique for every router.
Okay.
And by default, maximum path are 4. What does it mean? From source to destination, it will be used 4 path. For routing table, in routing table, store the 4 path, the information. If you want to extend up to 16, yes, we can extend the up to 16 also, if you want. Likewise, up to 16 also. It will be load balancing up to 4 path. And it is a classless routing protocol. What does that mean, classless routing protocol? It is a classless routing protocol. Classless routing protocol. So whenever we are advertising some prefixes, so class full routing protocol will not carry with subnet mask. It means whichever the class full means class A having the subnet mask 8, class B having 16, class C having 24, right? So that up to that prefix only they will advertise. Class full routing protocols means they won't carry, they will not carry with subnet mask. But in this routing protocol, they will use, if you are using 25 and 26 and 27, they will carry with subnet mask. OSPF and EAGRP and ISIS, all the protocols are classless routing protocols. They will carry with subnet mask information. What does it mean? By default, auto summary is disabled. See, in EAGRP and RIP protocol, so whenever you are advertising the prefixes, that time it will be auto summarization, it won't do. So in this prefixes, it will be summarization. So but by default, auto summary is disabled here. So it will be used shortest path algorithm. And just before we discuss here, it will be used as a metric value cost reference bandwidth by reference bandwidth is equals to 100 by Mbps to 100 MB to by interface. So based on this formula, it will work. Based on this algorithm, it will work. It will be SPF, shortest path first algorithm. It will be work. And one more, we call it as a Dijkstra algorithm also. We call it as a Dijkstra algorithm also. This is all about OSPF. And how the packet flow is there, we'll discuss. Do you have any questions in up to here?
No, Ali.
Good. So we'll discuss now packet types, and as well as we'll discuss some messages. Here in OSPF having the 5 message types in that hello message, database description, and DBD, and LSR, link state request, and link state update, and link state acknowledgement. How they will work, we'll discuss. So these all are these types of messages, and we'll discuss as well as states. We'll compare how they are work. Here we have 6 states. OSPF having 6 states. Down, init, two-way, and leave about it, attempt, and start, exchange, loading, and full. So here we have the 2 routers, and router A and router B, we configured OSPF. In between, we configured OSPF, where first we configured here OSPF with the command router OSPF, then IP process ID. After then, only we configured here this router, not for this router. So that is down state. Means one side only we configured. So this router A started the process. Still we haven't not configured at both end. So that is, we call it only one side we configured. This router is started sending the hello packet. Hello, myself, router A is sending the packet, but this router is not giving the reply because we haven't configured this router. So even though we configured at one side, we have not configured in this state. So that is route init state. So what we'll do, we'll configure both end OSPF. Then they are sending and receiving the hello packet, hello message. Hello myself A. This router is sending A. And this router also sending A. That is init state. So we advertise some prefixes. So they together, they are sending the name. We configured, once we configured, then it will be moved to the init state, then init to two-way state. In two-way state, they started the process, database description, they started two-way state, they started the packets at sending and receiving. So hi myself router A, and this router also sending hi myself is router B. So how many prefixes we have 100 LAN prefixes in this router, and this router also having 100 LAN prefixes. So this router is requesting. So do you have any database? So can you send the database? And in this two-way state only, and DR and whichever router having router ID, they are starting the router ID is also sending. So if this is a BDR. If this router having prefix like a 1.1.1.1 and this router having 2.2.2. This is a router ID. They started to sending that router ID entire thing in the two-way state. So it will be elected as a DR router and it will be elected as a BDR router. So in two-way state, it will be happen. So once they send a router ID entire thing in two-way state. After then it will be moved to the extart stage. In extart state, it will be elected whichever the router having router ID best one, that router will be elected as a router. They that router will be elected as a DR or BDR. Sorry, in extart state it will be election. Apart from that, in extart state they will exchange some content also. In that content, size of sequence numbers and MTU size and master and slave election also. In this extart state only it will be happen. In this two-way state, they form the neighborship. Apart from that, they are sending whichever the router ID is. This router having router ID that is 1.1.1.1 and this router having router ID 2.2.2. They are exchanging the information. That is database description. In extart state, they are elected which one is the DR, which one is the BDR. Apart from that, they are sending some MTU size, maximum transmission unit, and sequence numbers. Sequence numbers means how many prefixes having you have, and this router having how many prefixes, router A. With the basis of sequence number, they will exchange. They will start to elect as a DR and BDR. After then, they are exchanging the entire prefixes, LAN prefixes. How this router will request? Okay, do you have any prefixes, LAN prefixes, router A, and router B will give the update. Yes, I do have. Then this router will be give the acknowledgements. So here how it will be happen in exchange state. Router A and router B. Router A having 100 prefixes, LAN prefixes, and router B also having 100 LAN prefixes. So router A requesting, do you have any LAN prefixes? Can you give me? So router B is updating. Yes, I do have 100 prefixes. So can you give that? Yes, he will give in update state. L S U update. L S R request. Then this router is giving LS ACK acknowledgement. Likewise. Once they establish, then it will be moved to the full state. Now both are exchanged information, then the full state. That is full state. Loading, then full. In two-way, so in two-way state, one more router also struck. That is, so this is DR. This is the designated router, and this is the, for example, this is a BDR. So one more router also we have. This one is DR other. Other means non-DR routers. So this all the routers will struck in two-way state. Two-way state only. So whichever the prefixes they have, they will share with DR router. DR router only, master router only share whichever the needed routers. If this is A and B and C, D. If this router wants to communicate, router C, so it will be moved. First it will be moved to DR router, then DR router 2, it will be likewise. It will be go likewise. If he want to discuss with him. So they are struck in two-way state only. Non-DR routers will struck in two-way state. and up to full state, DR router and VDR router only move, because they only responsible to share the whichever they wants to communicate, whichever the routers the other routers wants to communicate. So for this, some neighborship parameters we have. So some neighborship parameters we have. So what does that mean? Neighborship parameter means whenever they are sending and receiving hello messages, so some need to match some neighborship parameter, then only neighborship will be formed. So router ID must be different, area ID must be matched, and if so, what does that mean? Area ID means to stop the LSA flooding. So we have if we have multiple routers, here we have router A, B, C, D. This is a one class, one area 0, can assume, and we have another area. This is the area 10, and we have another areas, area 20. In this area 20, we have multiple routers again. So likewise, area must match, then only they form the neighborship. These routers will not form the neighborship. So authentication type must match, and subnet mask, if we are configuring here 1.1.1.1.1, and here same subnet we have to configure. Same subnet we have to configure. If the subnet is different, so that time also they will not form the neighbor. So here you configure as a 1.2 1.2.2 1.1.2.2. If subnet is network ID is mismatch also, they will not form the neighborship. And hello timer and dead timer. So what is hello timer? Hello timer is 10 seconds and dead timer is 30 seconds. In dead timer, they have to match. Dead timer and hello timer. MTU size also match. Maximum transmission unit. So 1500 by default. This also match. So these all are the neighborship parameters. So some types of routers we have here. So router types we have here. So types of routers in OSPF, backbone area. All the interfaces are in this area 0. So the just now we discussed it. This is a area 0 and area 0 having 4 routers. This all are the backbone interfaces. This is the backbone interface. This is a backbone interface. This is a backbone interface, because these all the interfaces is in 0. So internal, all interfaces are in non-backbone area. So this is non-backbone area, you can assume. And ABR router. So at least one interface is in backbone area and one interface is in non-backbone area. That router is called as a ABR router. So here area 0 and this is area. This is a area 0, you can assume, and this is a area 10. So here we have multiple routers again. Likewise, in between one router also is there. This is a router, and this is a area 0 routers. Likewise, so whichever area 0 and area 10, different areas, this router we call it as a ABR router. This router we call it as a ABR router. One interface, at least one interface is in backbone area. This is backbone area, and one interface is in non-backbone area. So that is we call it as a ABR router. This is a ABR router. So ASBR router. So same thing. but different what is there. This is a in router, and this is area 0 as well as OSPF we configured. OSPF we configured, and this is we configured as a EHRP. So we redistributed these prefixes in this router. We call it as a ASBR router. ASBR router. Area Autonomous System Boundary Router. Autonomous System Boundary Router. One interface is in OSPF and one interface is in another protocol, different protocol. Any different RIP also you can assume, BGP or any different routing protocol. That is, we call it as a ASBR router. And here we have some different LSA types. What does that mean? So whenever we are configuring on OSPF, here we have some kind of LSA types. And types of LSAs. I'll give you the overview. So router LSA, network LSA, and summary LSA, and ASBR, summary LSA, and external LSA, and multicasting OSPF LSA, and not so stubby LSA, not so stubby area, external LSA. So what is router LSA means? So router 1 and 2. Here router A and router B, in between we configure OSPF. So this router having some information, whichever having the OSPF information, that is comes under how, see, if this router having 100 prefixes, 100 networks. So this all the routers having same in this router only. If this router only having, this is the LSA type, that is router LSA. That is, we call it as a network LSA. So in between segment, once we configured, so here this is the DR router and this one is the BDR router. So BDR router and any other router also. See, this network is sending his all the interfaces, all the 100 prefixes this router having, router C having. This router, he is sharing his prefixes to router A, that is, we call it as a network LSA in between. So summary LSA, if we configured, this router will maintain summary LSS, means ASBR router only established, ASR router only ABR router only generates summary LSS. ABR router only generate summary LSS, and ASBR router, whichever the router having in between two different protocols like OSPF and EHRP, in between we have a one router. That router only originate ASBR LSS, Autonomous System Boundary Router LSS, and both external LSA also. This router LSA4 and LSA5, who is originating, who is establishing LSAs, that is LSA4 and LSA5 will be originate ASBR router. So whenever you will do the multicasting, that time it will be happen. And not so stubby area means if this so whenever we'll in LSA 7, if we don't want LSA 4 and 5, because this router having, so this is 100 prefixes and this one is 100 prefixes and this is 100 prefixes. These all are coming through OSPF. This is LSA 1 and LSA 2, and if we configure any different area, then this router is originating again ASBR, area border ABR router originating some LSA 3 summary LSAs. So, and 4 5 there are redistributed prefixes, means here thousands of prefixes this router is coming. So those kind of prefixes, if we don't want, means just will give one default gateway, default route to him, and will minimize this 4 and 5 LSS with the basis of not store stubby area, will give one default route. This is all about the LSS, LSA 1, 2, 3, 4, 5. Just name wise, just remember it. This is all about the OSPF. Do you have any questions? Shall we move to the lab?
Yeah, we can.
Okay.